Welcome back to another episode of What the Hack. In this episode, we will be covering two very cool and useful topics in programming, indexing and slicing. Indexing is a very important and useful concept for working with lists and other types of data. Imagine if we had 5 of our friends lined up in a queue based on the initial of their first name. We can keep track of them using programming with a list like this: Abby, Benjamin, Chloe, David, Ella. Indexing is essentially what we just did with our friends in the queue. Abby gets the first index in the list, Benjamin gets the second, Chloe gets the third, David gets the fourth, Ella gets the fifth. Indices tell us which element is in which position inside our list, or in our example, which friend is in which position in the queue. Just like how we would count 1, 2, 3, 4, 5 when we call out the name of our friends in the list, indices are also represented by integers. One important thing here to note is, unlike most human beings, computers start their counting numbers from 0. A computer would actually count 0, 1, 2, 3, 4. And when it comes to indexing, we will need to count in the way that computers count. So in our example, Abby, the first friend in our list, will get index 0. Benjamin, the second friend in our list, will get index 1. Chloe, the third person in our list, will get index 2. David will get index 3. And Ella will get index 4. From now on, we will use 0, 1, 2, 3, 4 instead of 1, 2, 3, 4, 5, or first, second, third, fourth, fifth, for simplicity and better understanding. When we want to use index to extract information from our variable, such as a list or a string, we can put square brackets immediately after the name of our variable and have an integer or an expression that results in an integer as the index value that we want inside the square brackets. An example of an expression that results in an integer is a mathematical operation, such as 2 minus 1, because the result is the integer 1. With our friend list example, if we want to know which friend is in the second position in the queue, we will put 1 in the square brackets immediately after our list, like this. Why do we put 1? Remember that our computer counts 0, 1, 2, 3, 4, instead of 1, 2, 3, 4, 5. And the integer 1 is the second number when our computer counts. Now if we print it out, we can see that Benjamin is the second friend on the list. Something special about Python is that it supports negative indexing. That means that we can put negative integers inside the square brackets, and when we want to extract information out of our list, a negative index goes backwards when looking for the information on our list. For example, the last element of our list will have an index of -1. The second last will have -2, and so on. So in our friend list example, if we want to know which person is in the last position of our list, we can simply put -1 inside the square brackets and print it out. And it will show us that Ella is the last person on the list. Now that we know what indexing is, it is a good time to revisit some of the list methods that we learned about in the previous episode, as well as some of the other list methods that utilizes index to help us play around with information in an even easier way. The first one that we're going to look at is the pop method. In our previous video, we learned that this pop method removes the last element in our list. With this method, we can actually specify which element we want to remove from the list by specifying the index inside the bracket. For example, if we want to remove the element at index 1, we can specify 1 inside the bracket. Remember that when we use the pop method to remove the element from the list is automatically updated. If we save it, we will be actually saving the element that is popped out. If we run the code, we will see that Benjamin has been popped out of our list because Benjamin was at index 1. Assume that we don't know which index an element is at. We can use the index method. In our friend list example, if we don't know which index David is at, we can specify David inside the index method. This index method will return an integer, or it will give us a number, and this number is David's index. The insert method serves a similar purpose as the append method, which is adding elements into the list. But the insert method gives us more choice of where to add a new element at. Instead of just appending the new element at the end of the list, we can use this method to insert an element into an index in our list. By passing these two pieces of information inside the brackets, For example, if we want to put a new friend Chris into our queue and keep the friends lined up based on the initial of their first name, we know that Chris will need to be before David because C comes before D. This means that Chris should be in the 4th position. Similar to how the pop method will actually update the information stored in our list, the insert method will also automatically update the information in the list without us needing to save it in the variable. When we print out our list after inserting Chris into the 3rd index, we can see that now Chris is at index 3 and David and Ella get moved to 4 and 5 respectively. And because we added one more friend to our friend list now has 6 friends. Slicing is another very useful concept that utilizes indices. It is used for taking a small part of information out of our data, and it's quite flexible. For slicing, we will also use square brackets immediately after the name of our variable, but this time, instead of only having one integer, we can have up to 3 different integers. These 3 different integers serve different purposes, and we separate them with a colon. The first integer is the index that we want to start at. The second integer is the index that we want to go until but not include. And the third integer simply tells Python how many elements we want to skip when we slice. For example, if we have a list of our friends and we want to get the name of the friends at position 1 and 3, but not the others, we can specify the start index to be 1 and the stop index to be 4, which is the position immediately after the position that we want to stop at. And then we can specify the skip value to be 2, because we want to take every other name starting from Benjamin. As you can see, Benjamin and Chris are included in the sliced list, but Chloe isn't. The reason is that Benjamin is at index 1 on our list, and the slicing skipped every other name starting from Benjamin. And the index number of the next cell equals the index number of the previous cell plus the number of cells to be skipped. So in this case, 1 plus 2 is 3, which is the position number of Chris, so Chloe isn't included. The reason why Ella isn't included is because we specified the stop index to be 4, which told the slicing to not include David and anyone after David because David is at index 4. Note that we don't necessarily have to specify all 3 integers. If we don't specify the start index, then the slicing will automatically start at index 0 of our variable. As you can see, because we didn't specify the start index, the slice list now has Abby as the first element, and because we specified the skip value to be 2, the slice list has every other name starting from Abby, which we will have Chloe because we skipped Benjamin. The reason why David isn't included in the slice list is because we specified the stop index to be 4, meaning that we want the slicing to stop right before index 4, which is right where David at. If we specified the stop index to be 5 instead, then the slicing will end right before index 5, which is where Ella is at. Thus, David will be included. If we don't specify the stop index, then the slicing will go till the end of our list. As you can see, because we specified the start index to be 1, the slice list starts with Benjamin because he is at index 1 on the list. Because we specified the skip value to be 2, the slice list takes out every other name on our list. Thus, Chloe is skipped, but Benjamin and Chris are included. Finally, because we didn't specify the stop index, the slicing takes everything from the first index till the last element on our list while skipping every other name. Thus, Ella is also included on the slice list. If we don't specify the skip value, then slicing will simply take everything from the start to the end that you specified. Or better, you don't even have to include the second colon. As you can see, because we specified the start index to be 1 and the stop index to be 4, but nothing for the skip value, the slicing started at index 1 where Benjamin is at, and ended right before index 4 and index 3 where Chris is at, while including every single name in between. And negative indices work for slicing as well. If you specify the start index to be -1, then slicing will begin from the last element on the list. As you can see, because we specified the start index to be -1, but we didn't specify anything from the stop index, the slicing begins at the last element of the list and stops at the last element on our list. Thus, only Ella is included on the sliced list. If you specify the end index to be -1, then the slicing will end at just one element before the last element on our list. As you can see, because we didn't specify a start index while specifying the stop index to be -1, the slicing automatically begins at the first element of our list, but ended right before the last element of our list. Thus, everyone is included except Ella, because she is at the last element of our list. And if you specify the skip value to be -1 instead, then the slicing will actually print out the elements in our list backwards, as compared to if you specify it to be 1 and prints it as a list as it is. As you can see, our list is reversed. Because we didn't specify a start index or a stop index, the slicing automatically started at the beginning of our list and stopped at the end of our list. Indexing and slicing also work on strings. If you look at the characters inside a string as elements inside a list, you will know that each character inside a string, there's an index associated with it. As you can see, the element or the character at index 7 in our string is a lowercase e. How we slice a string is the exact same as how we slice a list, with square brackets, colons, and up to 3 integers, and it will work the exact same way as a list. Remember that blank space is also a character, so it would also be a part of the slice string in our start, stop, skip settings happen to include them as well. Both indexing and slicing are very helpful in working with a lot of information. Check out the challenges to see how these two cool programming tricks can be used in real life. That's all for our 7th episode. Thank you for watching, and we'll see you guys in the next episode. Till then, be safe, wash your hands, and wear a mask. Or just be safe.